We've all kicked a soccer ball in our life, or at least attempted it. But do you really understand the physics behind this seemingly simple action?
Here's a soccer ball at rest. The only two forces that are acting upon a soccer ball at rest are the normal force caused by the surface or the force of gravity, pulling it down. And this is at rest because the two forces are equal and there are no unbalanced forces. There may be smaller forces that are being put upon the ball, but they are too small to consider.
When the soccer ball is being kicked, there are three forces acting upon it. There is the force applied, which is being caused from the foot kicking the ball. And then there's also the gravity force, which is pulling the ball down. The friction force happens when the ball is in air. Air is matter and friction is always present. Friction is the reason why the soccer ball will always slow down. People sometimes confuse gravity as the force that slows down the ball.
But really, all gravity is doing is increasing the friction because it forces the ball down against the ground and that's when the friction occurs.
The net force of the ball is friction. The ball is kicked one way, but it is accelerating the opposite way, so the ball will always slow down. When kicking a soccer ball, all three of Newton's laws are present.
The first law states that any object at rest will tend to stay at rest, and any object in motion will tend to stay in motion, unless acted on by an unbalanced force. This applies to soccer because before kicking a ball, it is at rest. In soccer, the unbalanced force is usually the foot. Once the ball is kicked, it would stay in air, but because of friction and gravity, the ball will eventually slow down and drop to the ground, like we previously mentioned using the force diagrams.
Newton's second law states that the acceleration of an object is influenced by the magnitude of a force and the mass of an object. This is explained in the equation F equals ma. This means that if the ball is heavy, it won't accelerate as much as if the ball was lighter. If you want the ball to move fast, you must apply more force in the kick. If you just want to make a short pass, kick with less force than a hard shot.
Newton's third and final law states for every action there is an equal and opposite reaction. When kicking a soccer ball according to this law, the soccer ball kicks back at you just as hard. It doesn't feel like the ball is kicking back at you, but it is. But your leg has more mass than the ball, meaning it has more inertia, so it has more resistance to movement.
Newton's third law also applies for things like heading in soccer ball or juggling. You exert a force on the ball, but then there's an opposite and equal reaction, so the ball is also exerting a force on you. Even though you have more mass, therefore more inertia, so you don't accelerate as much as the ball does. So as you can see, kicking and handling a soccer ball is a lot more scientific and complicated than it seems. Once you better understand the forces behind kicking a soccer ball, you can probably better understand how to play the game.
It wasn't recording. I was trying to get the right angle. Yeah. It already is.